Okay, so the vertices of an ellipse are always on the longer side of the ellipse. Center is the point HK. The equation, x squared over a squared plus, this is very important for an ellipse, is that plus, y squared over b squared equals 1. We have a note that we need to make sure we are aware of. Ellipses should always equal 1. So if you ever get your equation and it's equal to something besides 1, you divide so that the equation is equal to 1, which is why we have these fractions for ellipses. Okay, so sometimes you're going to have to divide the equation in order to get it equal to 1. But an ellipse should always be equal to 1. So how do we graph these things? From the center, on the x-axis you're going to go a distance in both directions. So whatever that a coordinate is, the one that's attached to the x's, that's where you're going to go right or left in both directions. And then on the y-axis, you're going to go b distance in both directions. So for the b's, you're going to go up and down both ways. Okay? So, example 1. What we want to do for these examples is identify the center, the vertices, and sketch. So, our first equation, x squared over 25 plus y squared over 16. I first need to find the x's. What is my center here? Any ideas? No, not quite. These are a's and b's, not h's and k's.
0 and 0.
0 and 0. So the center is 0, 0. Remember, h's and k's are attached to the x and y's. Okay? So I guess a better way to write this would be x minus h squared, right? Oh, sorry. And y minus k squared. X minus h, sorry. Sorry. So x minus h squared and y minus k squared, those could also go here. Okay? And they both should be negatives inside of them. Okay, so if nothing is attached, like in example 1, to the x's and y's, our center is 0, 0. So we need to find the vertices. Now we find there's going to be 2 sets of vertices for ellipses because we need the long points. So we need to find the x's and the y's. So x's are attached to the a's. So if to find x, we have a squared is equal to 25. So how do I solve for a? Square root. So a is equal to 5. To find the y's of the vertices, we take our b squared. So b squared is equal to 16. So we take the square root of both sides, and b equals 4. Okay, so to graph these things, we first graph the center. The center is 0, 0. So let's put a point there. Okay, let's graph the a's first. A is the x-coordinate, so we're going to go to the right 5 spaces. 1, 2, 3, 4, 5. Put a point there. And then we're going to go to the left 5 spaces. 1, 2, 3, 4, 5. So you're going to put a point right there. This is not enough information to graph the whole ellipse. So then we're going to take the b's and count up and down. So we're going to go from the center up, 1, 2, 3, 4, and down, 1, 2, 3, 4. Now we can graph it. Okay, now same thing as a circle. You want to make it as smooth as possible. This one is a little circular, but one side is longer than the other. Are the x's longer or the y's longer? The x's. I didn't do a very good job. Okay, So try to make it as smooth as possible. It should look kind of like an egg. Okay. So remember, vertices are the longest sides of the ellipse. So are my vertices on the x's or on the y's? The x's. So these are my two vertices. So my first one is positive 5, 0. And then my second one is negative 5, 0. Example 2. Here's my equation. 4x squared plus y squared equals 36. Am I equal to 1? No. So what we're going to do is divide both sides by everything by 36. So divide everything by 36. And we're going to get a new equation. 4 and 36 reduces, right? To what? To 9. So that's going to be x squared over 9 plus y squared over 36 equals 1. This is the equation we're going to work with. Looking at the equation right away, what's my center? 0, 0. Okay, so let's plot that now before we forget. Okay, so let's figure out which direction I'm going to go in the x's. So that's going to be, we're looking at the number underneath x squared. So a squared is equal to 9. Take the square root. So a equals 3. So in the x direction, I'm going to go 1, 2, 3 to the right. 1, 2, 3 to the left. Now let's do the y's. B squared is equal to what? 36, right? So b squared is equal to 36. Take the square root of both sides. So b is equal to 6. So from the center, I'm going to go up 1, 2, 3, 4, 5, 6. And down 1, 2, 3, 4, 5, 6. Okay, so are my vertices on the y-axis or the x-axis this time? Y. The y's. Okay, let me see if I can do a better job sketching this one. It still looks pointy at the tip. Okay, so my vertices, what are the coordinates of my vertices? We have 0, 6, and 0, negative 6. Okay, what do you notice from examples 1 and 2 about where my vertices end up? On example 1, they were in the x's. Which number is bigger, 25 or 16? 25, the one under the x's, right? What about in example 2? They were the y's, and the y's are bigger. So you are going to be able to list the vertices eventually without having to graph it, okay? Example 3, you have x over 2 squared plus y minus 2 over 4 squared equals 1. Okay, we are not exactly in the form that we want to be in, so I would suggest that we rewrite it, and then I'll let you go off on your own. This is the same as x squared over what? 4. Over 4 plus y minus 2 squared over what? 16 equals 1. Okay, I want you guys to finish the rest of it on your own, please. Okay, so what is the center of this thing? What's the x? 0, and the y? 2. So we still need to take the opposite, okay? So make sure that you take the opposite, just like we've been doing. So let's graph that. 0, 2, 1, 2. That's our center. Okay, so in order to find the vertices, we first need to know how much to count up or down, left and right. So A's, or X's, sorry, has to do with the A's. A squared is equal to 4, so A is equal to 2. So we're going to go left and right 2. 1, 2, 1, 2. Y's have to do with the b's. So b squared is equal to 16. So b is equal to what? 4. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. Let's sketch that. Okay, I'm going to use no. I can do it. There we go. Okay, so that's what our ellipse should look like. So what are my vertices?
How'd you get B,
Are my vertices the B values or the A values? The B values. So we need to write down the coordinates of the vertices. What is the coordinate of this guy? 0, 6. And what's this guy? 0, -2. Okay, so on our first two examples, the vertices were always whatever A or B came out to be. Will not always be the case if your center is not at 0, 0. Did anybody see a way that we could maybe figure that out? Did anybody notice anything about from this one? What's my x-coordinate the same as? The center. So my opposite coordinate is always going to be the same as the center. The one that I'm actually using for the vertices, my b was 4. What's 2 plus 4? 6. What's 2 minus 4? Ding, ding, ding. Okay, so there is a way to figure it out without graphing. I would suggest that you graph it at first until you're fully comfortable without. Okay, so let's look at example 4. Okay, so example 4 here, we have to divide some stuff first. I'm not equal to 1, so we have to divide everything by what? 648. So divide everything by 648. Okay, so that's going to give me 72, and 648 do reduce. 72 goes into 648 9 times. So this is going to be x minus 1 squared over 9, plus 8 goes into 648 81 times. Okay. Okay, so now we are in the descriptive form. What is the center of this guy? 1, 0. Okay, let's hypothesize, because I want to practice doing this without graphing. Are my A's or B's going to be where the vertices are? The B's, because they're bigger, right? Okay, my center is not at 1, 0. So since I'm using the y coordinate as my vertices, what is the x coordinate going to be of both of them? No, it's not going to be 0. It's going to be 1. Okay, so because we're not using the x coordinate in our vertices, they're going to be the same as the center. B is going to be what? What's the square root of 81? 9. So 0 plus 9 gives me 9. 0 minus 9? -9. Let's graph it just to be sure, but that's what I predict the vertices are going to be. Okay, so let's graph this. To find my x's, I'm going to take a squared, which is equal to 9. So a is equal to 3. So from my center 1, 0, which is right here, I'm going to go right 1, 2, 3, left 1, 2, 3. To find how many I count on the y's, I take my b squared, which is 81. So b is equal to 9. So I go from the center up 1, 2, 3, 4, 5, 6, 7, 8, 9. And I go down 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then I sketch that guy. Okay, looking at my vertices, where are they? They are at 1, 9, and at 1, negative 9. So we figured it out. So what happens if I am given an equation of ellipse that is not in the standard or descriptive form? We're going to do the exact same thing we've been doing. We're going to group the x's. Oh, we can't group these x's. So x's are here. And group the y's. And then we have this 32 on this side. We want it moved over, so we're going to subtract 32 at the same time. Okay? So this is first going to give me 16x squared plus 96x plus blank. So we're going to end up completing the square again. Plus 4y squared minus 48y plus blank equals negative 32 plus blank plus blank. Okay. We can factor out a 16 from this guy. So let's factor out 16. So that's going to be plus...
Nurse's office. Hannah Colbert, please report to the nurse's office.
4 times y squared minus 12y plus blank equals negative 32 plus 16 times blank plus 4 times blank. Okay, this is a little bit different than what we've worked with before because these numbers are not the same. What we need to do here, it's going to be a little bit different than what we've done before. We are going to fill in the blanks. And instead of dividing the 16 and the 4 out of the left-hand side, we want an ellipse to be equal to what? To 1. So we're going to divide by what's on the right-hand side. Okay, so let's do that really quickly. What goes in the blank right here? 9. So this is a 9. What goes in the blank right here? 36. So this is 36. Okay, so this is going to be 16 times, this factors to x plus 3 squared, plus 4 times, this factors to y minus 6 squared is equal to, okay, this is negative 32 plus 144 plus 144, which gives me 256. Okay, this is considered standard form. Okay, this is the standard form. Okay, if we want to move on to descriptive form, because that's what's easier for us to work with, so if we want to move on to descriptive form, we divide everything by 256. And that is going to give me x plus 3 squared over 16 plus y minus 6 squared over 64. All of that equal to 1. Okay, so that's really where we want to go.